Okay, so hello and welcome to the 6th event in our series, We Need to Talk About AI. This event today is being rescheduled for March after the cancellation due to the strike and coronavirus. So the subject of today's session is really assistive technologies, which are to do with helping people with mobilities, with learning difficulties, with things like Parkinson's. And what we're looking at is what the current research is in this area with assistive technologies, how they can potentially help users, and also the ethical issues around those. So today we've got 4 speakers. The first is Anya Team. We've also got Frank Bros, Carol Chermutz, and Verity Ward. And so to start with, we're going to have 4 initial talks, and then we'll carry on to the panel discussion afterwards. So if you have any questions, please type them on the YouTube channel. And what we'll do is we'll wait for all the individual talks finish, and then we'll have a panel discussion, which will take your questions from the YouTube chat. So to start with Anya. Anya is a human-computer interaction researcher currently based at Cambridge. She's looking at how AI machine learning can be applied to real-world problems. One of her current projects is Project Alia, which is looking at how AI can be used in quality of care, and particularly related to mental health. So what I'll do is I'll hand over to Anya, and she'll be able to give an initial talk on her area of expertise.
Brilliant, thank you, David. I do have a few slides just to make it a little bit more sort of attractive talking virtually. So I'm going to share my screen. Okay, this works. I'm feeling I'm sharing the wrong screen. Okay, this is definitely the wrong screen. Let me correct this.
We can see your screen now. I can see your presentation.
Did you see it in full view, or
it's in the window desktop, but it's not in full view.
Oh, come on, technology, help me out. Great start, hey, sorry. Trying, okay, stop share, try again, try a different screen. Let's try this one. Doesn't seem to work. So still, how can I move this over? Oh, man, this is the problem when you have 3 screens, honestly. Can't recommend that. Okay, one more time. That looks right. That looks right. Okay, cool. Right, so as David was saying, I'm Anya. I'm a senior researcher working at Microsoft Research in Cambridge. And what I do is I do a lot of different work in the accessibility space. I've been working on a number of inclusive technology projects over the years, mostly in the healthcare and accessibility space. And so in particular, I think right now I do work a lot on AI technology for people with mental health problems, but I've also done a lot of work with people who are blind or have low vision to design quite innovative AI technology. And I'm going to focus on that part in particular for the introduction. And what's really important in all of my work is that I follow a really deep sort of human-centered approach to technology design that really tries to involve the people for whom we create the technology throughout, and really trying to design technology responsibly so that it can benefit all people and really aligns with their values and ethics. And so as a result, a lot of what I do in my role is really to conduct deep user research and ethnography, really trying to involve the people as co-designers and learn from their life experiences and ideas as well as, of course, what concerns and critique they might have about technology, especially when we talk about AI. And I'm trying then to bring these perspectives and people's voices into multidisciplinary research teams to ensure we create systems that people really want and appreciate in their lives. So I thought I'd make this most concrete by sharing just some examples. One of a quite positive and guiding example here is an app called Seeing AI. It's been developed within Microsoft and is a really popular app by the blind community. It uses computer vision technology to offer functionalities such as conversion of text to speech, or the detection of barcodes or currency or even other people. And one of the reasons that this app has been so successful is that its development was initiated and driven by people with lived experience of a visual impairment. So you see here Saqib. Saqib is one of approximately 40 blind engineers within Microsoft, and him and his colleagues actually started this app as part of a hackathon project, which then evolved into a product. And it's really because he brought in his ideas, but also personal experiences, that the app really offers authentic value and utility. And there's lots of different features. This is not even all that the app has, but one in particular is that you can take a picture of the surroundings, and then it basically creates an automatic caption for that image that describes what might be going on in your surroundings. And what came out of this research, but also some of the academic work, and you see here a reference to some academic papers, is that actually people who live with vision impairments take photos quite differently. You might get the obvious photos are taken that are blurred, they might be not lit properly, maybe the important parts could be cut off. And that can make it quite challenging for image processing, whether you're a human who tries to understand what's been shown in the image, or in fact a system. And what's also quite interesting is that maybe you could consider the types of images that people who are blind take to be a little bit more unusual. So maybe contrary to what you might think, they would want to take a photo of a coffee mug to identify it. Maybe a blind person would rather touch that object and kind of figure out that it's a coffee mug by themselves. That's maybe not a visual question they would ask. But maybe if they were entering, for example, a hotel room for the very first time, they might want to use computer vision to detect where the power sockets in that room, so I can recharge my phone. And that changes a little bit, the sorts of use scenarios, but also the kinds of data sets and training data that we need to create useful AI applications that really require a lot of image data to be captured by people who are blind. So there's some challenges bound up with that. Generally, of course, I guess we are quite familiar with pragmatic uses of computer vision, really helping us, as I was saying, to recognize text, money, barcodes, other objects. But we shouldn't forget that actually it's also really important for people to connect with other people. And a lot of our ethnography work and user research has shown that social relations and interactions are in fact crucial for how people who are blind come to understand their surroundings and really connect with others or seek help. So it's really important to think about these social relationships and how we can nurture them. And so we started to develop a computer vision system that will provide people who are blind or have vision impairment with dynamic in situ access to other people nearby. So they could answer questions like, who is around, who is perhaps here, who I know and could reach out to, where are these people, what are they potentially doing? And then these information are provided to the user through spatialized audio. And so with that in mind, we started to develop a prototype system, an AI system that comprises of a head-worn HoloLens device. We've kind of adapted it a little bit, so we chopped off the AR lenses because we don't need them. But at the top of the device, we have also computer vision technology that enables, basically camera technology, that enables a near 180-degree field of vision. So on the right-hand side, you can see 3 image parts that together create this 180-degree field of view. And in the middle, there's 2 colleagues of mine and myself, and we are detected in our pose, so you can identify people's bodies. You can also identify their identities. There's quite advanced computer vision, how far away a person is from the user and what they're doing and where they're looking. And at the bottom right, you see how frame by frame, we have like a 3D real-time tracker that builds up this model of where people are in relation to the user, where's the gaze direction of the user. And so you build up this understanding of where others are nearby. And as I was saying, we then have functionality in the form of a phone app or a wrist-worn device where you can then inquire information about those others from the system and get that feedback through spatialized audio. And so what we've done is we've done some user research actually throughout the development process with adults who are blind or have low vision. And we started to see that they made sense, for example, or used this information about others nearby in ways that enable them to proactively reach out to someone to socialize rather than having to wait for others to make themselves known. So for example, if you walk into a cafeteria space and there might be a friend in the top right corner and you yourself haven't had awareness of it and the person hasn't made themselves known to you, the system could provide you with that information. But it also can be useful to mitigate potentially sort of embarrassing social situations. So you may have been in a room with people that you know who are there, and you then start a conversation with someone who you thought might still be there, but they quietly left the room. So you can use that technology to double check, is this person still there? Where are they? Have they moved in space? Can I just orientate to that person, which especially sort of in professional work contexts can be otherwise a sort of sensitive or potentially embarrassing situation to avoid. What we also did more recently is work with a blind boy who was using the system with his family and at school. And then we discovered that he was using this AI system to have a better understanding where his friends are and whether they are looking around or looking at him, and so that he could actually start to better physically position his body orientation towards other people, indicate he's listening or make contact with them. And it enabled him to start developing his social communication skills a little bit better and to have a better understanding whether other people are focused on him or not. So it's quite an interesting sort of starting point to think about how you can use an AI system to build up fundamental skills and maybe learning experiences, and especially social skills, quite important considering that around about 2/3 of children born blind are being diagnosable with autism. So starts to touch on an interesting new opportunity on how we might want to think about AI applications. There's not so much pragmatics around, object detection, text recognition, and things like that. But of course, ethical challenges. We're talking about a computer vision system that can detect people. And with that, we don't just mean that they're present, but also who they are, their face geometry, their location, what they're doing, and other things if we wanted it to be, and that's quite sensitive. Data is a lot to consider, whether we should even capture such data in the first place, but if we do, how would you store it? How would you analyze it? And that's challenges that are not unique to this particular prototype system that enables us to do research, but other technologies that are already out there. And so we always have to ask ourselves what sort of data practices would we be comfortable with generally. But I think here in this particular instance, I think it's an interesting balance to be struck between we have unique opportunities through AI, maybe a certain responsibility to think about how AI could make the world more accessible, for example, to blind children or people who have vision impairments. And yet at the same time, we have to balance this with people's right for privacy. How do you mitigate that? What sort of compromises or trade-offs are you willing to take? And just as an inspiration to close, how we've been thinking to start addressing some of these challenges, apart from how we may not store face identifier, like personal identifiable data in the first place, but also how we might communicate the workings of the systems to other people. So on top of the HoloLens, we've attached this external LED interface, and it basically communicates what the system does to other people rather than just the user. So when a person's presence is identified, there's this white light that moves and mirrors the movement of the nearest person. And when that person is recognized in their ID, that light switches to a green flicker, and that indicates I've not just seen you as the system, but I've also identified you, and that's what I've communicated right now to the user. And this starts to create a little bit more transparency about the workings of the system, but it also allows other people to either work with the system to help it recognize them better, but equally to take themselves away from the situation and make themselves hidden if they do not want to be recognized. So it's starting to think about how could you create transparency in interactions and invite people in a dialogue here rather than just, having people use a system that is opaque in its functionality to others. Right, and that's me as an introduction. So I'm trying to stop screen share again.
Okay, thank you, Anya. So I've seen we've got a few questions on YouTube, which is good. So please keep asking questions. What we're going to do is we're going to wait until the panel discussion after all 4 speakers, and then we'll introduce the questions as part of the panel discussion. So just keep sending questions if anything interesting comes up or you want to ask anything. So our next speaker is Frank Ross, who's based at Heriot-Watt. And his main research interests are on human-robot interactions, AI. He's looking at design, and also particularly relevant to this talk, there's a Socorro robot project, which is about creating expressive robots for people with autism. So how robots and people can interact. So I don't know if Frank has got any slides or got anything.
Yes, I do.
Okay.
Yeah, so I'll just
yeah, so you can share now if you want.
Okay, cool. Let me try to get this started. All right. Just a second. Bear with me. All right, can you see my slides now? Is that working?
Yes, it's shared now.
Okay, perfect. All right. Yeah, thank you for inviting me. I'm going to talk about a couple of different projects that are all kind of fall broadly under the category of using social robots for robot-assisted therapy. So yeah, just to situate my work a little bit, I work in the area of social robotics. So with that, we do a lot of applications of various AI techniques to enable robots to interact with people. So it's a subfield of human-robot interaction. In social robotics, we're interested in leveraging what we know about human social behavior in order to make interaction with robots more intuitive and naturalistic. And because of this, we often use AI techniques to model human behavior so that we can understand humans and respond to them more naturally. And these types of interactions might be characterized by verbal interaction, but often because robots are embodied devices that can move through the world, there's a significant focus on nonverbal aspects of interaction. My application area is currently very focused on robot-assisted therapies, is as opposed to looking at therapy in a more medical robotics context where a robot might be a device or a machine that's physically interacting with a person. We're looking at these social robots as interaction partners. So the focus is on looking at how we can use them to deliver therapies in a way that increases engagement with the user and helps to maintain engagement with therapies and adherence to them over the long term. And we're looking at therapies in particular where we can leverage the fact that these are embodied interactions. So my current work, I'm working with 3 different populations of people that I'm going to talk about briefly, one of which are adults with an autism spectrum condition. Another group is stroke survivors. And finally, adults with age-related cognitive decline. Okay, so in the Socorro project, we are looking at delivering therapies for adults with an autism spectrum condition. and this condition can provide barriers to employment, despite people being fully capable of entering the workforce. And often these difficulties are related around social interaction and interpreting social behavior. So that's what we are targeting in the Socorro project. We are basing the therapy that we're focused on a paradigm called behavioral skills training that's been used effectively. There are multiple stages of this therapy, and we are not looking at kind of replacing the delivery of this therapy by a trained expert therapist. What we are focusing on is the rehearsal stage of this therapeutic paradigm, because this allows people to rehearse, as much as they want with the robot that's a non-judgmental interaction partner. So it's a kind of a supplement to existing therapy focusing on rehearsing skills. We're also interested in this project in kind of producing interactions that are ecologically valid. So we've been looking at having this therapy in sort of realistic workplace scenarios. And we focused on the skills of interpreting expressive behavior when it happens in work-related contexts, and also in dealing with interruptions. We know that interruptions can be especially challenging for people within ASC to deal with. This was feedback for this particular scenario that we hadn't initially planned to design something around, but through focus groups with people with autism, they told us repeatedly that this was something that they struggled with in the workplace. And so we designed a scenario around that based on their feedback. And we've produced, have published a little bit about that in HRI this year. And all right, and the next application area that we're working on is rehabilitation for stroke survivors. We know that rehabilitation can significantly improve the prospect of recovery, but often while people might in early stages of rehab get a lot of attention from the physiotherapist while they're in hospital, they're frequently sent home with not very good tools. They may just have some handouts or a DVD. It's not interactive. It's not very engaging. And then adherence tends to decrease, which isn't good for their long-term prospects of recovery. So we're looking at addressing this fall off in adherence through designing a robotic coach that could be used in the home. One of the reasons that people don't adhere to a program of treatment is it involves practice of a lot of repetitive exercises, and it can be quite boring and not fun in and of itself. So we looked at what coaching strategies people use to cause people to adhere to these type of repetitive exercise practice over time. And we're interested in looking at the coaching strategies of two groups of people. One, the physiotherapists that train and supervise rehab, but then also by analogy, coaches for individual sports. In this case, we're looking specifically at squash, because in individual sports, there's also a large aspect of doing repetitive drills on your own. And the coach has coaching strategies that use to kind of reinforce those behaviors and the adherence. So we have been observing both physiotherapists and squash coaches in coaching sessions, and we have interaction traces of the coaching behaviors that they have used during these sessions with different participants. We are currently in the process of clustering these interaction traces, and at this stage, what we're interested in looking at is whether these clustered interaction traces correspond to particular coaching strategies or styles that are subjectively recognizable to the expert coaches. Okay, And then finally, I'm just going to talk briefly about some work we're just beginning on using serious games for cognitive rehabilitation. These have been shown to be effective in kind of keeping cognitive training and keeping up skills and preventing cognitive decline. But unfortunately, adults who don't yet have a level of cognitive decline that would be classified as an impairment often have the lowest intention to use these types of therapies. So we're interested in looking at whether we can make these types of cognitive training more engaging with a social robot that is a kind of interaction partner to play these types of games with. We're also interested because there is a lot of varying factors in as people age related to kind of sensory processing and whether they have difficulties with hearing or vision, but also just what stage they're kind of at in their aging. So we're looking at a system that adapts to its user. It also gives cues through various types of multimodal feedback. And our goal in this work is to increase engagement over a long term in order to make these therapies more adhered to and then hopefully more effective. And I just wanted to end briefly with some ethical issues that commonly come up in my work in using socially assistive robotics for these types of domains. One thing that we're very careful to do when we're working with robotic therapies is that we never design systems with the intention of replacing a human therapist. We're always looking at a place where there are cases where people don't have access to therapy and the robot would create a new opportunity for therapy where one didn't exist before. It's also very important to listen to your users, as in the example from the Socorro project with the interruptions. That was a kind of a new scenario that came directly out of engagement with our users through focus groups. And increasingly, as I work in these areas, my work is moving more towards using participatory design techniques as a kind of a starting point in approaching these problems. And then finally, as already has been mentioned, it's important to respect your users' expectations of privacy and to be transparent about what kind of data you're sensing and collecting from them and how you're using it, because the robot is not just a, hopefully a social agent or an interaction partner. It's also a very, very sensor-rich device, and you might be moving it into areas that are sensitive, such as a healthcare center or in the home. People need to understand and feel that they can trust what you're collecting and what you're doing with this data. And it's worth thinking about where this data is being processed and whether you actually need to make use of this. And with that, I would like to wrap up. Thank you.
Okay, thank you, Frank. And as I said, if you have any questions, then please put them on YouTube now, and then we'll ask them at the end, and we'll just start the panel discussion. So our next speaker is Carol, and Carol is a Mary Q Fellow at the Center for Speech Technology Research, and her main research is in prosthetics, and particularly signal processing and hearing. So if Carol is ready, then I can hand over to Carol.
Yeah.
Okay.
Hope you can hear me and see me all right. Hello, everyone. Thanks for inviting me. So I don't have a presentation as in PowerPoint, but I have the props. So what I work on is improving the intelligibility of speech for everyone, but in particular for the hearing impaired population. So there are different types of hearing loss and different types of prosthetics that an individual can use. So I have here a hearing aid. I hope that you can see it all right. It's a very tiny device. So this model here is worn behind the ear. So I'll take an earbud off and you put it like this behind. And there's a tiny, tiny loudspeaker that you insert into your ear canal. So you can't even see it. It's very small. And it has microphones on the outer shell here. And then, well, usually you wear two. And they also exchange information with each other. So one major problem that we have with these technologies is that they are really small. And so all of the algorithms that we would like to put in these machines, we actually struggle to make them work in here because they are so small. So our computational capabilities are very limited. Like the processor is not powerful enough and the battery is not powerful enough because we have such a small battery. And so if you want to run a powerful algorithm and you have a powerful analog to digital converter, then the battery dies out very soon. And so obviously you do not want this. You want this to last for several days possibly, but you usually have to recharge them every day. But if you have to use something that is too powerful, then you would have to charge them maybe every 2 or 3 hours. Obviously you don't want that. And it's really, really difficult to run machine learning algorithms on these devices. So this is one of the major challenges that all of the industry faces right now. So there is a very wide breadth of research in this field, and there are very good academic results in this respect. And what I mean is that there are many researchers that are concerned with machine learning algorithms for hearing aids. And what they do is to suppress the background noise, enhancing the speech. So when you are in a noisy situation, like for example on the street or in a restaurant or in the car, you want to focus on the speech signal when someone is talking to you and suppress the background noise. So this used to be done in a procedural way with like classical signal processing techniques. And now the industry is looking forward to implementing these things with machine learning. But the problem is that it's really difficult to make it happen for real. And so we actually face the problem of a device that cannot support the technology that we want to use within it. And so what we are looking forward to is to find ways to scale these technologies, to have neural networks that are scalable, that we can compress and actually use in these devices. So these are the technical concerns, and I wanted to talk about this in order to give you an idea of what's going on. Because there are ethical concerns with these technologies, but to a certain extent, they are not a worry already. And I'll explain what I mean. So one thing that we want to try to do, for example, is automatic scene estimation. You are in a car, you are cooking and the fan is on, or you are at a party with many people. And what you want is a hearing aid or a hearing prosthetic in general that can adapt to the situation. And then also you want to separate the speakers. For example, if you have multiple speakers talking, you actually want to differentiate between them. This would be a really nice technology to have, but we are not yet there. So maybe some of you have seen the algorithms that Google has made with speaker separation, and they work really well. But in that case, you need to train a model, a very powerful model with many hours of speech. So how could you do that with hearing aids? I mean, imagine that you have these devices and you want to separate the speech of your child from that of your spouse. But what are you supposed to do? Record them both for many, many hours and then train the model for many hours? So that's kind of a difficult thing. This scenario is coming, hopefully. I mean, I hope that we can implement this technology, but we're not there yet. And there's many concerns about this from an ethical point of view, and they relate to what our speakers said before. So, for example, there will be other people in the scenario, like not just your child and your spouse, but there might be other people if you are out in the public. And how can you not infringe their privacy? Because you're going to record them somehow. And so how can you avoid that? And also, you want to differentiate between speakers that you know, but what about those you don't know? Imagine that you could actually separate speakers that are at another table in the restaurant, and you could like pick one that you want to listen to. Would that be ethical? Now, given that at some point this will be possible, is it the right thing to do, and who regulates that? So I think that we need to talk about a common framework for these technologies. In Europe, we have the GDPR, which is really good. I mean, it's good that we have started thinking about this in a global way, but this doesn't stand for all the countries in the world. And so I think that we need a global framework for this from a legal point of view. So I think that all the companies that develop these technologies, not just the academia, but the companies both, should always have an ethic panel to talk about these concerns. But also there should be like a global board, hopefully, that can make sure that these regulations are respected, because otherwise you'll never know where your data goes. So we've spoken about recording or seeing strangers, but also what about your personal data? So now many manufacturers are looking into turning these machines also in some healthcare, more comprehensive healthcare tools. So something that can also monitor your bodily data, like for example, your heartbeat or your temperature. But then where is this data stored? And how are they going to use them? Are they going to sell them to a third party? What kind of research are they going to use with this? And are they going to use this in a way that you are not aware of? So these are all concerns that that we should have about this thing. Do I have any more time?
You can take some more time if you want to, yeah.
Okay, so I'll mention also another technology, because I've spoken about hearing, but also there are speech technologies that I think are affected by the same problems as privacy is concerned. So I have another prop that you all have in your house, which is this, your phone. So this is something that I regularly use, which is speech recognition. So I don't type my messages, I speak to my phone, I dictate. So what happens to that speech? Where is it processed? So it's not processed on my phone, but the data is recorded and is sent somewhere. There is a cloud computing this thing all the time, and I don't know where my data is sent. Like in the beginning, when I bought the phone and I download the software and I click yes, there's a very long terms of use to read that nobody really reads, but you agree to that and then you use it. And then you don't really know what happens to this. And then once this data is sent, some of it is stored, especially when you say a word and your phone doesn't really get it right and you correct it. Actually, that's something of interest to the company that gives you the service, because they want to see what you said and what was not right. So there might be a person that is checking that manually. And can they know who you are? Can they listen to you speaking? Do you want them to know what you were saying? So it's kind of tricky. It's like that kind of problem that we would not think about, but it's there. So I guess that the consumer has to be aware of where their data goes and how it is handled. And like in the case of a person that needs assistive technologies, of someone who cannot type, like this is the only thing that can be done. So yeah, I invite everyone to think about these issues, and I hope that we can establish a common framework for talking about these privacy issues. Thank you.
Okay, thank you, Carol. So now we come to our last speaker, who is Verity Ward. And she studied a few years ago doing the MSc in Speech and Language Processing at the University of Edinburgh. And she's now doing a PhD in Southampton with the Autism Community Research Network. So I don't know, Verity, if you're ready and you can, I don't know if you've got slides or not, but.
Yeah, I don't have slides. I'm just gonna talk at everyone. Hopefully that's okay.
That's fine, you can start now.
So hello everyone. As David said, I'm Verity, and I'm a PhD researcher at the Acorns Lab in Southampton. So the Acorns Lab is made up of researchers from education and psychology, and we work closely with community partners in nurseries, schools and other educational settings to research, understand, develop and share good practice for the education of autistic children and young people. So my research focuses primarily on the process of participatory design. So we heard Frank mention this earlier. And I'm really looking at participatory design as a means of mutual learning between autistic children and young people and other partners in the design process. So participatory design means designing with rather than for users. Its history stems from Scandinavian workplace democracy movements in the 60s and 70s, and the main aims are to ensure that the voices and experiences of users are incorporated into designs. So in my first study, I'm looking at a collaboration with a local special school who works specifically with autistic pupils, among others. And together, along with representatives from the technology industry, we're going to design, build and evaluate some computer games and examine what we've learned in the process of doing this. So, as I said before, I'm really looking at the mutual learning that happens throughout the participatory design process. And this is not just for me as a researcher, but also for other adults who might be involved. So this might be typically technologies designers, it could be other experts by experience, and the young people themselves. So the important thing about participatory design is that it really ties in with the view of students as experts in their own lives, which is important for the strengths-based approach we take within the Acorns Lab. And it's really closely related to the first issue relating to ethics that I wanted to mention, which is the issues of agency of the users. So agency relates to the extent to which people are able to make decisions for themselves about how and what they engage with. And it's really important with respect to the current topic, because we need to consider, with respect to assistive technologies, what we're designing, who decides what we design, and perhaps who decides what gets productionized and made available to the people who can use it. So we do quite often within academia develop these amazing tools that actually don't end up being made available to the public, which is a real shame, because it means that they just get locked away in, I don't know, GitHub or something, that someone can access the code, but it doesn't actually ever get put into anything, which is a real issue. Other issues that I think it's important to consider when developing technology for autistic people and also other disabled people are: how are the intended users involved in the design decisions? To what extent are their views allowed to shape designs? And how can we ensure that engagement in the design process is meaningful for those people and not exploitative? Sorry, I've got a There's someone cutting down a tree outside, so if you can hear a chainsaw, that's what it is. I apologise for the noise, and if I get distracted by it as well. Within my own work, I face lots of different ethical conundrums, particularly with respect to the ethics that I try to practice during my research and how these conflict sometimes with the requirements by the university. So for example, the university requires informed consent from all participants who take part in studies. And as I'm working with people under the age of 18, this has to be and is required to be a two-stage consent process. So I have to get consent from parents before I can ask children and young people whether they want to be involved. And this is actually quite problematic in a lot of ways, because it denies the children and young people the opportunity to be recognised as capable knowers and decision makers who can decide for themselves whether or not they want to be involved. Formal ethics procedures also suffer quite often from being quite inaccessible to the people who you want to work with. So I'm sure those of you who are current students have signed ethics forms, consent forms for other people, or have made them for themselves, and they're often quite lengthy and wordy written documents, so that's not always appropriate for the type of people that you might be working with. So as a consequence of all of this, and highlighting the agency of the autistic young people, which I work with, I've chosen to do a co-productive research design, which means that their views are equitably captured as well. So yeah, I think that's pretty much everything I wanted to say as a starting point. Hopefully people have questions and I can answer them more then. Thank you for listening.
Okay, thank you to our panelists for all of their initial talks. So what we'll do now is we'll have a panel discussion with questions, and I see quite a few people have asked questions on YouTube. If you want to ask any questions to an individual panelist or to like a group question, then please put it on YouTube now. And I think Prakash has been looking over the YouTube questions and sort of collating them. And is Prakash on the line? Are you there?
Yep, I'm there, but it will be Faisal instead who'll be doing that.
Oh, okay. I thought it was you who was asking. But I get an anonymous chat. I couldn't see who it was.
Cool. Yeah, I'm sorry about that. So first question actually is for Anya. So how can we actually ensure that the data sets are diverse enough to accurately detect different phases?
I think that's a general problem, I think, of face recognition software to date. I think in the last 2-3 years, the problem of data sets being quite biased and not representative of different ethnographies and different types of people has been raised quite predominantly, and a lot of effort is being done in the machine learning community to ensure that more diverse data sets are being created. So that's, I think, a problem generally for any sort of face recognition software. I think for the technology that we create, we do things in 2 stages. We once detect people's body only, where you just pick up on people's skeletons. And that works actually quite well, even if parts of the body are occluded, so you don't even need to have robust face recognition. And especially if people have not given consent to being actually identified, that's something that's a little less invasive. For those people you want to identify, they actually have to donate pictures of themselves, of their face, in order for our algorithm to train their face geometry. And so for that, we have a few training images. Typically, only a few are needed to get that face vector really well established. And with that, you have the training data that you need to recognize the people who are your family, your friends, the people that have given permission to be recognized. And we think a lot on really quite carefully about, do we need to then even save any of the original images? Are we just having that numerical vector? But related challenges, just to bring that up, is we also have GDPR and people's right to be forgotten, and we want users to have control. So maybe one day you have given you images and you've been friends with that person and you've given them permission to be recognized, and maybe one day you want to retract that. And so how do you do that when you anonymize data or give data into a machine learning model that's then trained, and then you can't link that back to the person? How do you retract it and retrain the model without that person? So this is quite tricky to think about data storage and handling, and how can you be as sensitive to have as least person identifiable information in your system as possible, and yet have it linkable enough that you can control and delete from it. But because people have to give permission for their image and the images are fed in, that recognition should be better. Having said this, if we have seen in pilots that if you have a different, if people have a variety of different skin colors, that the system can perform more poorly when there's less images of, when there is less training data of people who have darker skin color. And so there is a higher chance that the system can make errors just because it's been traditionally trained on more images of white people. And that's something that actively needs to be addressed and worked on, but the community is working on this generally in face recognition. It's not just specific to projects that we do, for example.
Does anyone else have sort of comments on that particular question? Because obviously sort of biases in the data sets and diversity of data sets is quite relevant to what you're doing as well, maybe. I'm not sure. Anyone else want to come in? Anya or Frank or Verity? Okay, I guess we'll go to the next question. So do we have another question?
Right. Yeah, actually one important issue that has been asked multiple times is, how do you balance privacy with the functionality of what you're building? So that question actually has been asked to multiple speakers. So whoever can pick that up first.
Well, I can start.
Okay, Carol.
Okay, for example, for my research, I run a lot of listening tests within the university. And so when the participants come, we give them instructions and the terms of use of the experiment. So we tell them, we are doing this for research and your participation is totally voluntary and you can leave the experiment whenever you want. And your data is going to be used in a anonymized way for research purposes. So it's important that you always give the participant the knowledge, like what is going to be done with your data. And we tell them where it is going to be stored. Is it going to be within Europe or not? We're not going to give it to third parties and this kind of stuff. And so I actually have them read the information sheet every time before starting. So I do this as an academic, but if you are doing this within industry, you have to do a similar process. Because, for example, when you buy the hearing aids or another assistive device, the company, or well, the health expert that sells it to you also needs to tell you all of these things. You need to have like an informed consent of how your data is going to be treated. And of course, then as an academic or as a company, I want as much data as I can to actually improve things, because only if you have a lot of data, then you can actually make systems that work and that are not biased. But then I think that there is a fine line. So of course, who wants to work with data needs a lot of data, but also then you need to make the participants or the customers well aware of what is going to happen. And like personally, if I have to use an assistive device, or if I am a participant to an experiment, I understand this. Like I am okay personally with my data being used in a anonymized way for research, but I don't know if anybody else is. So I guess that like transparency and clarity in these things is key. And if anybody else wants to add something.
I'll jump in on that if that's okay. So I think it's interesting what you've just said about expecting the same level of informed consent from industry and within academia, because my experience of it, and I think a lot of people's experience of it at least, is that when you're dealing with a fully productionized system, often, as you said before, you scroll through to get to the bottom of the terms and conditions where it probably says everything about where your data is being stored, and you just click OK at the bottom. Whether or not that's actually an informed decision on, you want the functionality, and a lot of the time consumers and users don't necessarily care about, or don't care at the point where they need the functionality about what happens to that data. And so we skim through and we click OK on that with the T's and C's when perhaps we shouldn't. I don't know. I think it's difficult to say whose responsibility it should be to make sure that people understand.
But also there's a problem with that. So as we are discussing about this very long terms and conditions, I think that there should be, like, as I said before, a global framework, like a law like this should start from the government that says you have to inform your customers. And by law, it should be something short, like just the essential points, because sometimes I really sat there and read throughout the all of the terms of conditions of different products, and it's like mind-blowing because it takes hours to read it all. It's like 16 pages. Like, who wants to read that? No one, of course. So you have to make something simple. Yes, you can have a long version, but maybe save for later, and just a few key points that you read in, say, maybe half a minute. That should be made by law, something that you can read easily, not 16 pages.
Yeah, I
10 lines.
Agree. And I think it's interesting that we don't expect the same level of clarity from industry that we do from within academia at the moment. Because I know personally, in order to get studies approved, the level of detail and clarity that you need within information sheets and consent forms, if that's the way that you're delivering that information, is much higher than you would expect from an industry terms and conditions form.
Yeah, I think. Sorry. No, go ahead.
If you would just want to follow up with a comment, go ahead.
We just wanted to say that our forms, actually, they are maybe 1 page long. And I guess that we say kind of the same things. It's just very down to the bone. Like, we take away all the bells and whistles, and it's just the very essential information. But yeah, just that.
I think for industry research, at least, we do have to go through the same rigorous processes, and sometimes they're even more rigorous because we're in industry and because there is more concern that we might do something devious. And also, I think in a lot of big companies, especially, there's a lot of visibility if you were doing something unethical and that would come out. It could be very damaging to the reputation of that company and the trust that customers would have. So I think that has made actually a lot of, at least the big companies, very careful as to what they do and how careful they are. Now, that's different in research perhaps to what you described, which is you have an app perhaps, or a product you're using, a technology, be it a hearing aid, and you want to understand, how's my data being processed? How is it collected? And yes, terms and conditions are really inaccessible, but I do think there are, fortunately, some examples at least going into a good practice where the onboarding of an app explains, here's the kind of data that I'm capturing and what that functionality enables. So here's why we need to track your location data. And sometimes you could choose to disenable that, or you have a selection of what of the data are you happy to share with that provider. And it's really part of that onboarding rather than the T&Cs, which have to kind of tick a lot of the legal requirements and that people really do not read usually, unless they're Carol and they spend a lot of time going through the details. But yeah, so typically end users will probably install the app anyway, but then in the onboarding, you have that opportunity to make things a lot more easier accessible. The problem then still, this comes back to the original question, is when you then choose not to have certain functionalities, data sharing enabled, then you don't usually get the full benefits of the app. And I think this is where you know, we are always in a tricky situation for how much data are you comfortable to provide and what functionality does that enable. And so the best practice there is to really think about what's the minimal data that you need to provide a particular functionality. How can you do that in the most privacy preserving manner? I think there had been a tendency to just take as much data as you can, as described, right? Because we want that most complete picture of reality. But that's very invasive on people, and especially when you can't really justify why you need all that data, and maybe you don't need all that data anyway to do the specific task you're trying to perform. So thinking a little bit more carefully about the benefits you're creating. Are the benefits worth it at the end for an end user to agree with that data being shared? Would be a good question to ask from the start. If I feel the benefit that I'm getting for that data and the data is really carefully looked after would warrant for the permission to be given, then I might feel a lot better as a customer to share that data. But I want that transparency. I want it to be easier communicated. And it also requires to not go with that, you know, I would say older model of let's get everything we can and we're not saying why, and we might not even need all that data. So I think being a lot more on a need to know basis is also a good approach.
Okay, thank you. Do you have another question?
Yeah, so the next question actually would be directed to Frank. And how economic do you think, like how feasible would the robots actually be? So like, do you see them being mass deployed anytime soon, or do you think like they'd be subsidized by the government, or can you elaborate?
Yeah, I mean, that's a great question, and that's something that we are starting to increasingly, think about when we're designing these things. And it's becoming more affordable. It depends certainly on what capabilities your robot needs to have. Like a robot that's capable of manipulation, they tend to be quite heavy and expensive. They can also be not so safe. But we see these socially assistive robots that are more focused on interaction and don't necessarily have to have powerful arms or the ability to manipulate objects. You can make kind of a smaller, cheaper robot, and you can see through robots like the Pepper, we are increasingly having robots that are commercial products that, while not incredibly cheap, are something that's conceivably affordable, especially if they could be deployed in some way as a shared resource where they could be owned by a care home or a council, and many people could access that robot, and it would kind of amortize the costs. I think they're becoming increasingly kind of financially viable.
Does anyone else want to comment on that, or kind of like something relevant to what you're doing? Okay, so we'll take another question if you've got another question.
Yes, so the next question is for Carol. So regarding like training the voices, like do we take the context of the setting? So for example, if you're talking to your spouse and there's a child playing, like your child's playing in the background, like it shouldn't be as sensitive, like to shouts and screams in the background as, for example, if you were alone. So how would you take that into account when training the algorithms?
Well, so that's a very complicated problem because we are talking about two problems here. One is recognizing the speakers. So we have multiple speakers and we want to identify who they are in order to focus our attention on them. And then the second problem is the automatic scene estimation. So at the moment, there are some hearing aids that have this functionality. They offer automatic environmental acoustic scene estimation. I personally don't know how well they work, but I know that it's out there. And so you have these two different problems that intertwine, like what kind of situation am I in? And who are the people speaking? So this is kind of a difficult one to solve, because we are not there yet in solving brilliantly either of them. So the combination is quite tricky. I would imagine that in a situation where you have multiple speakers, whether that is your spouse and your children, or it's like different people, the hearing aid would adapt itself automatically to the so-called cocktail party situation. This is a very well-known problem. You usually describe with this situation where you have multiple speakers and you want to differentiate between them. And so in that case, probably the algorithm would focus only on one of them, but which one? So that's the problem. Because how does the hearing aid know who you want to listen to? That's very tricky. So at the moment, we have technologies that work and not just via machine learning algorithms, but just with directionality of sound. So on the hearing aids, as I was showing you before, you have these microphones in here, and you have multiple microphones. You have at least 2 per hearing aid. And so what they do is to get different signals, and they can tell the position of objects. Because since you have, it's like having multiple antennas, basically. And so you can tell where something is in space. And you can make these microphones very directional. And so with directionality, you can actually focus to something. So for example, I want my algorithm to recognize what is in front of me. And so if you have one person speaking here and one here, you can just turn your head, and then the hearing aids will use something that is called beamforming, which is a technology that stands for sounds, but also for electromagnetic waves. It's basically focusing on the signal in one direction. And you can use this, like the beamforming technology, in connection to the speaker separation, for example. You could put these 2 things that are actually operating in different domains, you can put them together. Or also now there's a lot of research in actually analyzing brain waves with EEG. And so some researchers I know are building like miniature devices that you can put behind the ear with electrodes, and they are trying to analyze the attention of the listener. So in a cocktail party situation, they are trying to see through your brain waves where your attention is. And the hope is that you can actually put this in the hearing aids at some point. So analyzing via your brain waves where you want to focus the attention, and then place it on the person. And you can use a combination of all of this, of the brainwave scan, of the speaker separation, of the beamforming. And so there's a lot of technology they want to put in this one. I'm not sure if I have answered or just made more confusion than before, but so the long story short is that you have a lot of different technologies that we are trying to put together, and hopefully they will work with some good result at some point.
Okay, thank you.
Yeah, next question is actually for me. So also for Carol. Instead of compressing the algorithm so that they work on the small hearing aids, can they instead be used to gather the data and send it to a more powerful server for like processing?
Yeah, absolutely, absolutely. So there is no device that I know of that does it, but maybe I just don't know it. But for certain, this thing does it. Like all of the speech recognition that you're doing on different devices goes to a cloud. And there's also different services, because Apple has one and Microsoft has another, and then Google has its own. And it's all computed elsewhere, not on your device. And it's actually a lot more powerful. So for hearing aids, there are different things that you can do. Of course, as I said, this is too small, but you can pair it with your phone. And so you could have some of the processing done here. And this is already happening. Like usually you have an app, you have Bluetooth, and you pair them with your phone. And so you can do some of the computing here. But also, I think that at some point, we will use this as we do for speech recognition. So the data will be sent to a cloud, for example, for the scene estimation. Like understanding whether you're in the park, in the car, or in the restaurant. It can be analyzed and then done on a cloud server for sure.
Okay. Next question is from Richard Cave. So the question is actually, so if people with dysarthric or impaired speech, would that be distinguishable to the hearing aid tech as normal speech?
So that's also another big problem. Sorry, the question was for me, right?
Yes, of course.
Okay. So there's a whole branch of science that studies how to correctly recognize impaired speech. So I personally know some researchers that are working on improving the intelligibility of impaired speech, like people that had some surgery or after a stroke. And so they are applying machine learning methods to take these signals and actually make them sound more as a normal speaking voice. And so this is one side of the problem. And then the other side of the problem, the people that work on speech recognition are trying to make systems that are more flexible. So you try to train them also on data of speakers that have impaired speech in order for them to be a bit more flexible and recognize this. I mean, this is a problem with accent already. Like if you are not a native speaker, or if you are from a specific region with a very strong accent. I think that probably all of you have seen on YouTube the videos of the Scottish people trying to speak to the elevator and it's not recognizing the command. So it's already a problem just within the accent. So you can imagine how difficult this is when you actually have impaired speech. And so you have these two branches studying like how to make more flexible recognition systems and how to build devices that improve the intelligibility. Hope I replied.
Yeah, thank you very much for that. Actually, this answers also another question that we had about bias, but in this technology. So yeah, accent is definitely bias. So yeah, thank you for answering that.
I have a question that we missed out from earlier. I think we skipped past it, but there was one I saw earlier from Sigrid, and it says in participatory design, how do you deal with the different levels of baseline knowledge of the stakeholders, e.g. on regulations and ethics, so that you can have a constructive conversation, so really about the design process. So I guess that could go to everybody, but I'll start with Anya.
It's just taking time. Like I think a lot of our involvement with stakeholders are longer term. So typically a year and a half to really bring them along a journey. The same way that our design development of technology takes time. So it's a journey of both learning from our participants, but also educating at the same time. I feel like the area that I'm working in, there is the dilemma that maybe regulations are a little bit more behind. So they sometimes want advice on how to best regulate. And a lot of the research brings about, I would say, more questions than necessarily answers as to how to go about this and what good practice might be. But I think we're also quite cautious that we're not trying to prohibit everything straight from the outset, but we try to understand how in different contexts technology comes to play out and what the implications would be from an ethical point of view and for different kinds of people, and really force our teams to think through all the sort of perhaps unanticipated consequences that our technology could have. And that is also a conversation to have with the stakeholders or the people that we are designing for that are involved in those processes. So I think it just needs a lot more time and conversation and discussion to really not just bring people to the level of understanding of what is the status quo perhaps, but also have the conversations of what are the concerns that we should be considering going forward. But the problem here often is that level of dialogue is needed, but at the same time we also have pressure to advance technology fairly quickly. And I'm obviously in a tech company that loves AI technology and wants to kind of do a lot of breakthrough, and sometimes I feel a lot of my role is to try and pause and kind of caution that, yes, we do want technology advancements, but we also need to reflect carefully as to what it is that we're doing and do this well with people, and which is where participatory design sits as well. So definitely not an easy thing to do.
Can I ask Verity, do you have any?
Yeah, I guess what Anya said there is sort of the crux of the problem, that really you need good relationships with the people that you're engaging with in order to be able to firstly decide where you pitch the information that you give people, and to make sure that that information is accessible to those people. So for example, within my own research, I actually have 3 different sets of information sheets and consent forms for the technology industry representatives who are involved, for the parents of students, and for the students themselves. And each of those information sheets and consent forms would include slightly different information and be written in a slightly different way to make sure that that information is accessible to the people who are receiving it. Additionally, I've actually taken the step within my own research to move away from that written documentation, especially in terms of relaying information before people decide whether or not to consent. And so, for example, in my first study, I also actually did a in-person sort of information presentation where people could not just read what was going to happen, but hear from me what was going to happen, so that that dialogue between me and the students' parents was a lot more open, that they could actually ask questions when I was there, rather than receiving a letter at home and then being like, oh, well, I'm going to have to ring the school, or I'm going to have to email someone, or to find out what they want to know, if that makes sense. Hopefully that sort of answers and adds on what Anya's just said.
Yeah, I don't know, Frank, if you want to comment, because I know obviously you're doing robotics, which is a more physical thing.
Yeah, I mean, I agree with what both Anya and Verity have said. I think what's really key in the kind of participatory design work that we do is this, having the dialogue and the education, because I think often people need you to work with them so that they understand what's possible, so that they can really kind of get into the phase of design. And so we work with people about that to kind of set up a design workshop in such a way that they have the information that they need to kind of start giving us their ideas.
Okay. So something.
Oh, sorry, David. I just had one more thing to say about that.
Of course, Verity, yeah.
Frank reminded me of, and that is that because with participatory design, you're working with multiple stakeholders, often and not just one. It does happen on a regular basis that you actually get conflicting information from different stakeholders, and often you have to balance the views of which stakeholder view you want to prioritize within a design in order to make decisions about what you're going to do, basically. And that's sort of inherent in the model of participatory design. Because you're listening to multiple people, you do end up with that tension and conflict often, and you've got to make decisions about whose views you prioritize.
That's something I was going to ask about Frank about, because in your presentation you mentioned about you wanted the design to work with existing therapists rather than to replace them. But kind of related to this kind of design process, is that something that there's a push towards sometimes, that actually these people should be replaced, we can automate this, or is it kind of more collaborative?
I think that probably because we're coming from like maybe a research perspective rather than a company perspective, we're not starting with the idea of, we could save money by cutting staff. So that's never a motivation in our work. And often one of the things that's really important for us on an educational level, in order to get buy-in from our stakeholders, because the viewpoints of therapists are massively useful to us. And one of the first things we have to kind of communicate to them about is that we're not trying to replace you. That's not what this project is about. The robot is a supplement, because I think often when you start working with assistive technologies, particularly in therapy, people can feel, I think, rightfully quite threatened that might be an agenda of the work.
I might chip in here as well, because I also work in the mental health space, more on sort of digital interactions rather than robotic interactions. But I completely share Frank's perspective on not trying to replace humans. And quite often when we talk about AI and we're moving towards this automation idea, and there can be a lot of excitement. And I'm always quite scared when I see how much funding currently is released to the idea of automatizing therapy, conversational interfaces in particular, chatbots that replace therapy, and thereby you have a technological solution, as I would call it, to the demand for more and more mental health services. And I think that's, to me, that is personally a little scary, because I think there's a lot of ethical implications that aren't addressed in this, set aside of whether the technical feasibility challenges can be solved, but about how are we sensibly introducing technology into what is a very sort of complex dialogue, perhaps between an individual whose mental health difficulties can be quite unique, and that who might have quite high expectations as to how they are being supported, and a tech kind of having to provide this automatically, I think is a very ambitious goal, to say the least. But yet, at the same time, I think there's so much enthusiasm and funding to try and make that a reality that I sometimes wonder, can we not find solutions where we might, augment perhaps the capabilities that therapists already have, expand a human sense of care, where perhaps some of the more burdensome tasks can be done by the technology, but not always go down that route to, let's replace the human, let's automate, let's move it away from human agency and control. I think there's a lot of danger there. And I think especially, I don't know why in therapeutics context, especially in mental health, there seems to be an exciting go-to solution for many companies right now. And so I would be interested to hear what others might think about that. Do they share that enthusiasm? Are there concerns as well? But definitely, the conversation about, are we replacing clinicians? Are we, as soon as we have a technology that is powerful enough, rationalizing that the cost-benefit ratio is better if the tech takes over? Is that going to be the mantra? So curious to hear your thoughts.
I was just going to, hello. I was just going to add on to that. So I think obviously in therapeutic contexts, there is no reason why we should be aiming to place, rather to augment, as both Anya and Frank have said. But there are contexts in which actually at the moment we have humans doing things that could be done by assistive technology, which perhaps is not the best use of the human's time. So for example, in the classroom setting, there are technologies available such as reading pens, which you can use to skim over text, and then it reads it out loud to someone who has headphones on. Now, if a TA is released from having to read something out to a student every time they have to read, if they struggle with it, and they've got a reading pen instead, then that TA could perhaps focus on other things where their skill set might be better used, if you see what I mean. So we can definitely use assistive technology in a way that replaces some human work, but in a way that redistributes those humans so that they can be used more effectively, if that makes sense. So we're not necessarily cutting them out completely. We're just saying, actually, what's the best use of your time? How are you most effective?
Thank you, Verity. Carol, do you have any comments on what we've heard so far? I guess not.
Yeah, sorry, I was muted. So maybe I can comment on the fact of substituting the human. So I think that there are tasks that can be automized and tasks that shouldn't. Also, in my case, I have just developed an algorithm that is called the automatic sound engineer. But this doesn't mean that I am trying to obliterate sound engineers from the world. It's meant to be a complement. So something that actually makes life a bit easier especially for professionals, but it doesn't substitute them. At least I hope not. Like, this is not my intent. Like, what I want to do is to create tools that actually can automate the parts of the work that are mundane and boring, that don't actually require any artistic touch, but just the things that if you're a professional or not, you don't want to do by hand. So some things I think are great to be automized, but not everything. So I think that the human factor is always very important and should be there. So I differentiate between these two things, and I don't think that everything should be automated.
Yeah, I mean, I totally agree. And I think it's probably a part of our responsibility as technologists to kind of be an advocate for keeping humans in these vital roles. One, by being realistic about what technology actually can do. There are lots of things that people want to automate that is just completely unfeasible, and you couldn't do a good job at it. But even if you could, I think there's a lot to be said for saying, this might be technically possible, but there are so many additional benefits people get from having this provided by a human, that taking the human away from it, it really does have a knock-on effect that's quite detrimental. So I think that's something that we need to, be prepared for, to advocate when we kind of move into these spaces as technologists.
Okay, thank you. One very quick question that was right at the beginning for Anya, and it's from Robin Hill, and it says, in the context of universal accessibility, is there a reason that Seeing AI is an Apple-only app?
Well, so I can't answer really for what's on the roadmap for this as a product, but what I can say is, as I was saying in the beginning, this actually as a project evolved through a hackathon. So I think it just gradually evolves. I think they have done a prioritization for making it accessible in, I think, 70 different countries, and covered lots of different languages to kind of increase the range, and focused, I think, on Apple at the starting point, because a lot of people who have vision impairments are preferring Apple products, especially phones, because it's more accessible than other products. Now, clearly that's a privileged group of people who then have access to that kind of technology. And there's no reason why this can't be expanded to other operating systems as well. I think it's just the way that the engineering has started from the hackathon project that it initially was, to what is still a fairly small engineering team that tries to support an incredibly growing user base. So yeah, this is not to say it can't be used in other operating systems, that just hasn't happened yet.
Okay, thank you. Faisal, do we have any more general questions? Or?
Yes. So a question came in from Emma Pritchard saying, how do you make a decision about which stakeholder view to prioritize?
So Verity, do you want to start?
Yeah, so I think that that really depends on what perspective you come from to begin with. So within my own research, I'm really focusing in on the autistic children and young people that I'm working with. So their views for me will really be prioritized, but equally there's always this toss-up between the objectives that you have for the technology that you're producing and the extent to which those stakeholder views can really be meaningfully integrated and used to shape the product. So often if you have a very narrow specification for what you want to build beforehand, the flexibility that you have within that specification narrows the extent to which people can contribute to it, if that makes sense. So it really depends on your perspective and what you want to gain from a project. So if you're focusing on building an educational app about, I don't know, learning about electricity, you might prioritize a physics teacher's point of view above the student's point of view. It really depends what you're trying to get from that engagement, I think, as to whose views you prioritize. And I think it's often it's often a dynamic process of deciding whose views you're going to prioritise as and when tensions arise between different stakeholders. I don't think people often anticipate the tensions that are going to happen where they do happen, if that makes sense.
Okay, thanks. Should we go to Anya, if you want to?
I think that's a really hard question because it so depends on the context and what you're doing and whose agenda is being led here. Because I don't think it's just about the agenda that the participants bring in and the different stakeholders you might involve, but also, you know, in a company context, you also have company agenda and there's politics involved and there's pragmatics of making technology reality. I think there's a lot of sort of ideas that we always have that it would be the optimal thing that we want to develop, and at the end we have to scale down quite a bit. So pragmatics coming in as well is not that easy to answer. I always feel at the end of the day it's often part of doing research, and it's hard to try and bring these different perspectives together. Some of these are really complementary, some of them are contrasting, and they are contrasting for different reasons, and developing that understanding and nurturing that understanding within the team is part of our job to try and do that as best as we can, kind of sensitize to what we are trying to achieve with the technology. But it's not necessarily that you can fully resolve this at all times, so that one perspective will win over another. You're trying to bring these in as much as you can, but it's really a complicated question to answer, I must say.
Frank, do you have any comments?
Yeah, I mean, I agree with both what Anya and Verity has said, and I think it is very much a process, and I think often through the interacting with various stakeholders, you find out, as Verity said before, some tensions, and often, you know, you find out a lot about assumptions that you were unaware of as a designer in your perspective that are revealed to you when you hear people kind of tell you things about how you know, how they expect technology to be used, or what they find difficult or valuable about something. And so I think that, you know, just as you have to be ready to be kind of responsive to things that you didn't expect when you started the work. Yeah.
And Carol?
Well, can you hear me? Yes.
Yeah.
So as the other said, I think this is a very difficult question. And I think that there should be some guidelines from governments. As I was saying at the beginning of the talk, I think there really needs to be a common framework. And when I say common, I mean worldwide, on what matters the most from an ethical point of view. Like as a researcher, I put the well-being of the participant or of the patient always in the first place. But then, like, the question is more about, like, if you have different companies or if you have academia, like which opinion weighs the most. So actually, I think that, like, everyone should bear in mind that, especially for assistive technologies, the well-being of the user is the most important thing, and that should be prioritized. And then I think that, as I said, there should be some guidelines from above, like from a governmental point of view, on how things should be dealt with. So that's my...
Okay, thank you. Actually, a follow-up on that. So Carol mentioned the legal side of things there. Lots of the technologies that have been developed are actually sort of medical related, or in this sort of group. Do many of the regulations regarding developments of medicines actually apply to, or therapies apply to, these devices? Or is it kind of something that doesn't really apply that much? Say if you just develop something for like a heart or something like that, you'd have to go through like quite big approval, and it'd be like a process and things. Where is anything similar in this area that's actually in place?
Well, I could start. So when we do work with healthcare data to get access to this data and to do research on it, we go through the same rigorous approval processes that other healthcare research does go through, typically. And then there's also this new domain where the FDA has, or is in the process of developing more and more machine learning algorithms as a sort of medical device, even though they're not a physical device, but thinking about algorithms as nonetheless an intervention and different levels of severity of the impact that such an intervention could have on people. Take the example of diagnosing cancer or proposing the optimal treatment for a particular kind of person going forward. And how do you regulate and monitor the performances of those sorts of algorithms in a medical domain? That is technically a medical device. But coming up with regulations and frameworks of what is, for example, best practice of developing machine learning models, what is a good enough model to put into the real world, and will it perform there just as well as maybe on the training and test data results that we get outside of the healthcare context, is incredibly hard. Is really, really, really complicated. And, you know, as this is still a very new domain, there's a lot of learning on all sides. So even if you wanted things to be more regulated, be it through organizations like the FDA or governments, kind of devising what that standard should be and how we could conform to that, and how can we do good practice and what good practice or best practice would look like. I think we're still in that process of learning what that even might be. And then protecting that through processes is actually, I guess, still work in progress. Hard challenges.
So does anyone else have comments on that? And also, just to follow up as well, is this something the regulators are actively looking at? Are they kind of aware of these issues or not? So maybe Frank to start with.
Yeah, I can speak to this a little bit more general. So I think there's a distinction. I mean, especially if you're working within the UK, between whether something is being used kind of clinically and is being accessed by patients, or if it's kind of outside the medical system. And then there are different, regulatory expectations around that right now. And I think that. And I think that, really new technologies being kind of used clinically is still, as I said, it's quite challenging to regulate. And I think people are still kind of figuring out how these fit into kind of maybe systems of regulations that aren't really designed for them, that are designed for different types of older devices. So I don't think it's clear yet how this should be done.
Does anyone else have any comments, Verity or Carol? Okay. Do we have any more questions from the? I don't think we do we? So let me ask us like a general question. So to all of you. So if you imagine the field that you're working in sort of 10 years' time, what do you think the biggest changes will be, and also what are the biggest challenges that will be in 10 years' time? I know maybe you've covered it a bit on your sort of talk, but maybe some more detail. So I guess maybe start with Carol.
So one thing that I would really like to see as a change is for these devices to not be just associated with disability. So as you know, there are many devices that you can use for entertainment. So wireless earbuds, noise canceling headphones, and those kind of devices have a lot of technology on them, the noise cancellation, and also you can use them also for speech enhancement. There are some brands like Bose that have models of earbuds that are meant for entertainment, but you can use them also as hearing aids. They actually got FDA approval for that. And so I think that we need to start across the line from what is considered just a medical device, something that is just associated with disability, to something that can be seen as a device that the general public would like. Like, for example, if you think of glasses for eyesight, they are a fashionable item. Like you have Versace or Gucci designing eyeglasses. And why can't the same happen for these devices? Like, why can't they be fashionable? Well, that's because right now they don't offer anything more. But if they could actually offer these technologies that I was talking about, like speaker separation, then maybe people would like this kind of devices because they would offer abilities that were never there in the first place. Like eyeglasses that are very fashionable, give you a unique look. Then maybe some device that can offer you like more comfort when you go out to a restaurant and you are able to listen to your friends without any effort. That's something that everybody would like to have. So what I would like to see is a shift in the mentality, like devices that are actually, that can appeal to the general public. And so not be associated anymore just with disability, but as something that people would actually want to have.
Okay, thank you. I'll go to Verity. Have you got any? I think you're silent.
Yeah, sorry, I was just unmuting myself. So what would I like to see in 5 to 10 years' time? I think within the field of autism and technology, I'd like to see more, I'd like to see less medicalization of autism. Within the field, there's a lot of conceptualization of autism as an ailment, as an illness, something that needs to be treated. And I think really we want to be, or we should be moving towards treating it as a type of diversity. Neurodiversity is the term that's used to describe autism and some other neurological conditions. And it would really be to see more people understanding that it's a normal part of human experience, albeit one that makes some people's lives more difficult than others. And it would really be that the general population would start to make moves to make the world a slightly more accepting place for neurodiverse people. And I think that probably stands for all people who are disabled by society, that we see that as a society we see the role that we play in disabling people. There are conditions about particular humans that mean that they have impairments in certain ways, but as a society we are set up in such a way that means that actually the fact that you've built stairs rather than a ramp, you're disabling the person in the wheelchair because they're not able to access that building. It's not just a question of impairment, if that makes sense.
Okay. So anybody else got challenges?
I do like both Carol and Verity's sort of vision for the future of a more inclusive, less stigmatizing, less medicalized world. I mean, generally, I hope we don't have to wait 10 years, but in the near future that we do have better understanding of what, for example, AI technology can contribute to our lives and where it might not need to go or shouldn't go. So maybe we have a clear idea of what is sort of a desirable future of how we live with AI technology within our lives. How do you want it to be part of our lives? And for that, I believe it would be really nice if we were thinking more about sort of collaborative, interactive, hybrid approaches where we really think about how can AI and human interact with each other in ways that, feels is focused on the kinds of experiences from technology that we would like to have that adds to our lives, that augments human capabilities in responsible and sensible ways. And I feel like we have a long way to go to figure that out well. And there's a lot of ethical challenges and regulation challenges that we, in the last hour and almost 2 hours been touching upon. There's a lot of challenges to work through. So hopefully we've made some really good progress there and arrived at some sensible choices as well. In terms of where we might not want to bring these technologies, in which contexts, and need to prohibit certain uses to not cause harm. So yeah, I hope there's a lot more learnings to be gained.
Have we come to Frank?
Yes. So I think one thing, I think something that people working in robotics have been saying for, well over 50 years now, but I think 5 to 10 years, people will actually be using robots probably in their home and workplace. I think the big challenge around that is following on, from what Anya said, that there's a societal challenge that these robots are coming into our lives in a way that kind of enhances our humanity rather than as something that kind of takes away from options that people have and cuts off opportunities to interact with other people. So I think that's a societal challenge, and probably we have a role in that as technologists in educating ourselves and future technologists in the ways that we do engineering to kind of make sure that people have a kind of an understanding of the importance of inclusion and know how to kind of conduct engineering in a way that puts the user at the center, so that the technologies that they make, and often you can't fully understand how something will be used until it's deployed, but we can, if we're take the pains to educate ourselves on ethics and really think hard about these problems at the stage that we're designing things, I think we have a better chance of kind of creating technologies that are responsible and that enhance human life.
Okay, thank you. So I think we're coming towards the end. So I've got one more question from the audience, and then maybe one more wrap-up question. And the question is for everybody, and it's, is there a specific event that compelled you all to work on assistive technologies? And also I'd like to add as well, if people are interested in your research, what projects and groups and things can they look at to kind of for the future? So I'll start with Frank this time.
That's a good question. I think the one thing is I guess in general, I started working in the HRI side of robotics because I was interested in human behavior, and that kind of moved me into assistive technologies because you get to work with really interesting and diverse groups of users, and often you feel that that people are quite excited about the potential of the technology and that your efforts are quite often quite well received. So I find that very rewarding. And yeah, if you're interested in finding out what I and my colleagues are up to, I'm part of the HRI group at Harriet Watt, and we have a website that covers not just mine, but a number of projects that we have at the university and as part of the Edinburgh Center for Robotics. And then Socorro also has a web page where we've covered our progress in that project. So thanks.
Carol?
Sorry, but I was disconnected for a while. So.
Okay, I'll just go through the question. So the question was, is there any specific event that compelled you to work on assistive technologies? And also my follow-up where I wanted to know, what can people look at if they're interested in your research and kind of like want to read more about it?
Well, I can answer this one. So for me, it was basically a coincidence because I always wanted to be a sound engineer since I was little. Some people want to be an astronaut, some people want to be an actor or a singer. I wanted to be a sound engineer, always. At some point, I found myself working in medical research, and I realized that I could bring the two together, like medical research and sound. And so assistive technologies and hearing was like the perfect field where everything that I wanted came together. And it's really rewarding because you have the feeling that you're actually trying to make a change for the better in people's lives. So this is something that makes me feel that I am employing my abilities into something that can be useful to the community, but still I enjoy it so much. So that's for me.
Okay, we'll go to Verity next.
Yeah, so I think like Carol, I don't think there was any one specific event that sort of pushed me into the field that I'm in, it's really been a sort of quite windy trajectory for me to get here, having first started out doing a modern languages and linguistics degree. But I think it's partly motivated, as Carol said, by a desire to sort of feel like you're making a positive difference in the world, that you're overall you're going to make a positive impact in people's lives. And I think through my research, even if it's on a very small scale, you do get the impression that you are, even if sort of findings don't necessarily conclude that right until the end, you that connection you get with that I get with the autistic children and young people that I work with, I really feel like they benefit from that.
Thank you, Anya.
Yeah, I can echo actually much of what's been said in terms of motivations. There wasn't a specific event for me. I've always been super passionate about creating meaningful technology experiences, and I'm also quite a caring person. So more and more gotten into the space of how can you design technology that supports people's well-being, went into mental health, working with people with learning disabilities, and then got into the space of working with people with vision impairments. And I've never thought of this as being something like, oh, I'm specifically creating assistive technology here. I've always thought of it as, I want to create a technology that works, that enriches people's experiences, and, you know, in many ways, it pushes you to be more innovative, to think about, okay, here's perhaps somebody who has different kinds of abilities or different ways of making sense of the world. How are we using that as a design constraint that pushes us to be more innovative and think in other ways about what we might want to create? And often that has led to technologies that then were more accessible to even more people, and led to things that we wouldn't have thought about if we didn't even start working with people who had a different life experience. And you know, and we talked about participatory design a lot, and empathy, being able to be in a privileged position to learn about how someone's world experience is quite different to your own. It's actually a really enjoyable journey. When on top of that, you are being able to make a difference, even just in one person's life, that's really rewarding. So, you know, as you get more and more into this space, I don't think personally about it as designing assistive technology, but certainly something, yeah, that evolves over time as well as you're in that space.
Okay, I want to say thank you to all of our panelists, and also for everybody who joins us on YouTube, and people can watch it back later. We're looking to have more of these events maybe in a couple of months when the university comes back. They could be online, they could be in a physical room as well, depending on what happens with coronavirus. We also have another announcement from, I think, Faisal, you want to talk about our mini conference.
Yeah, indeed. So thank you everyone for joining, and hope you actually enjoyed it. So what we do have is the mini conferences, the mini ICML event, which is actually taking place next week. So what that is also like talks from researchers from the University of Edinburgh who are going to the ICML conference later. However, before they go there, they're actually going to share their research. So if you're interested in that, and please join next week. The difficulty would be a bit more technical than when you talk about AI, but it could be interesting nonetheless. Thank you for joining.
Okay, just say thank you again, and whoever's doing the stream, you can disconnect the stream.
Yeah, thank you.
I don't know if we're still live or not, but yeah.